So the last section in this unit focuses on multiplying polynomials. So we already did adding, and we already did subtracting. So just to recap adding and subtracting. When you add and subtract, all you're doing is combining like terms. It is an exercise in combining like terms. So when you add, the parentheses don't matter. You're simply combining the like terms. When you subtract, remember the first set of parentheses, you bring everything down the way it was. For the second set of parentheses, you take the opposite. Second set of parentheses, you take the opposite of everything. That's the same thing as taking the minus sign and distributing it. And then after that, you combine all your like terms. Main thing to keep in mind is your final answer must be in standard form. So standard form is when you start with the biggest exponent and you can go down to the smallest exponent. Start with the biggest and work your way down. That's a quick recap of adding and subtracting. Any questions with either of those two? So let's look at multiply. So multiplying. So when you multiply, if you know how to do distributive property, then you've done multiplying already. The only difference is that when you multiply, you will change the exponents. So remember last week, when we added and subtracted, all you did was add and subtract the numbers in front. You did not touch the exponents. So if you did 7x squared plus 5x squared, that's not 12x to the fourth. You don't touch the exponents. You only touch the numbers in front. When you subtract, that's not negative 2x to the 0. You don't touch the exponents. You only touch the numbers in front, the coefficients. When you multiply the numbers in front. So 2 times 3 would give you 6. But you add the exponents. So p times p squared. So if you just have a regular p, that's p to the first power. P to the first times p to the second. You add the exponents up, that's p to the third. So when you multiply, you are going to be adding the exponents. When you multiply, you're going to be adding the exponents. Any questions on that before we continue? And those of you at home, remember the people in the classroom have the advantage because they can just throw their hand up and I can answer it, or I can go right to them and look at it. So if you're at home, make sure you type it in the chat or come off mute and answer. So as far as multiplying goes, there are 2 ways that we're going to do it, 2 ways that it's going to be shown. One of them is using distributive property. And the other one is called the area model. Area model is known as a Punnett square. So I don't know where you all are in biology. I don't know if you've done Punnett squares or if you've talked about Punnett squares yet. We use something similar in math to do multiply. Now, when you're doing your work, I don't care which way you do it. If distributive property works for you, then you do that for the rest of your life. If Punnett squares work better for you, then do that every time you multiply. I personally don't care. Figure out which one is going to work better for you, and that's the way you roll with it. So you're going to see me doing it both ways in class today. Any questions before we continue? Sound good? Straight? When you get stuck somewhere, I'm going a little bit too fast, speak up and say something. So, we'll do example one. We're going to do it regular way that we've been doing it, which is distributive property. So we've got 4x times 3x squared minus 4x plus 7. So let's review a couple things in regards to terminology. So last week, we talked about names of a polynomial. We talked about a name of a polynomial. So 4x, there's one term. So 4x, it's one term, so it has a name that begins with the letter M. It's a monomial. Three x squared minus 4x plus 7 has three terms, so it has a name that begins with the letter T. Trinomial. So we have a monomial, one term, times a trinomial, three terms. So yes, part of the review on Thursday, we'll be reviewing those terms and things of that nature because they will show up on your Unit 7 test. But when we work the problem out, we're doing distributive property the same way that we've been doing. So 4x times 3x squared. 4x times negative 4x. And 4x times positive 7. So again, I'm writing it this way so that you can see each part. You don't need this part and this part. So let's multiply it up. 4 times 3 gives you 12. And then x times x squared. So remember, when you multiply variables, you add the exponents. So that's x to the first times x to the second. So 1 plus 2 is what? 3. So 12 x to the third. And if you're multiplying the same variable, you add the exponents. If you multiply the same variable, you add the exponents. Let's keep going then. 4 times negative 4 is negative 16. What's x times x? X squared. Keep the variable, add the exponents. Remember, multiplying, you are adding exponents now. Go ahead. Absolutely. If there's no exponent there, it is understood to be a 1. The only way it can be a 0 is if it's a 0 up there. The only way it can be a 0 is if there's a 0 up there. And the last part, 4 times 7 is 28. You bring the x down. So you got 12x to the third minus 16x squared plus 28x, and that is your final answer. So if it's not in standard form, you put it in standard form. In this case, it's already in standard form, so there's nothing more that you have to do. So our question was, Do we still have to put it in standard form? The answer is yes. In this case, it was already in standard form, so we have nothing to worry about. You all good with example 1? Maya, you okay back there? All right. You sure? Okay. All right. So example 2, we're going to set up a Punnett square. So this is the other way to do it. Now we're going to go back and forth between the two. 3p times 4p squared plus 9p. So, just to review terminology. 3p is one term. What's the name of it? Monomial. 4p squared plus 9p, that's two terms. So its name begins with the letter B. Binomial. So monomial is 1, binomial is 2, trinomial is 3, 4 and above is a polynomial. So this is how we set up a Punnett square. So 3p is one term. So 3p goes on the top, 3 goes on the left. 4p squared plus 9p goes on the top. So we set it up in boxes. Hopefully your box is a little lot better than mine. So now we multiply. So 3p times 4p squared. 3 times 4 is 12. P times p squared. P to the third. Fill in the other box. 3p times 9p. 27p squared. So your answer is 12p to the third plus 27p squared. That's how you set up a Punnett square. Again, that's a small one. Are they always going to be that small? No. That's a small one. Again, I personally don't care which way you do it. If Punnett squares work better for you, then you do it for every problem that you have. If distributive property works better for you, then you do it using distributive property. I have to show it both ways because I have to teach 22 students. Any questions on 1 or 2 in here?
Are you going to be a test? Make them find your kind of like if you take a test?
If you take a test, I'm not going to tell you which way you have to use. If you prefer Punnett squares, then you do Punnett squares. If you prefer distributive property, you distributive property. Your work, when you submit your work, that's going to show you. It's going to show you which way you did it. Any questions from anyone at home? And they'll be at home. Remember, you should always be taking your notes because you don't know if you start flushing your notes. People in the classroom, it's easy. All I do is take a picture of it. So, example 3. So, example 3, now we have a binomial times the binomial. Binomial times a binomial. So we're gonna first do it using distributive property, and then we're gonna do it, example 4, using Punnett squares. So when you distribute, everything in the first parentheses goes to the second. So everything in the first goes to the second. That means you're going to take x and multiply it times x plus 11. And then take 6 and multiply it times x plus 11. Everything in the first goes to the second. Everything in the first parentheses goes to the second. Any questions so far? Everything in the first goes to the second, if you're distributing. I need you to speak up. I can barely hear you. Multiplying two variables, right? So when you multiply two variables, that means you're going to be adding those exponents. So that's something you're going to have to drill down for yourself. Every time you multiply two of the same variable, you have to add the exponents. Drill that down real good, because remember, IXL is going to mark it wrong if you don't put the right exponent. So x times x is x squared. X times 11 gives you what? 11x. Positive 6 times x gives you what? 6x. And then 6 times 11, 66. We finished our multiplying. Hopefully Julissa, Brooklyn, Evan has got these notes down. Good. There you go. You combine like terms. See that 11x and that 6x? You have to put those together. Those are like terms. If you leave this way, that's wrong. So the first two problems, there weren't any like terms. You didn't have to worry about like terms. They weren't there. Problem 3, there's like terms. So we got to put them together. 11x plus 6x is 17x. Remember, when you add, you do not change the exponents. Adding doesn't change the exponents. Multiplying does. Adding does not change exponents. Multiplying does. Any questions with that 30? Everybody? All right, then example 4. So we're going to do this problem using Punnett squares. So when we set up the Punnett square, again, if you did it using, if you've already started example 4 with distributive property, don't feel that you have to erase it. So take the first parentheses, either put it on the top or put it on the side. That's your choice. So I'm going to put 2y minus 3 on the top and put y minus 5, y plus 5 on the side. So I should have 1, 2, 3, 4 boxes. 4 boxes to work with. But now we multiply it like a multiplication table. So y times 2y should give me what? 2y squared. Then we do y times negative 3. Negative 3y. 5 times 2y. Let's see. 10y. So plus 10y. And then 5 times negative 3. Negative 15. So we finished our multiplying. Any questions on the multiplying part? Let's see. Trent, go ahead. Nope. So if you set yours up as 2y minus 3 and y plus 5, you should get the same answer. So, now look inside your boxes. Do I have any like terms? What are my like terms? 10y and negative 3y. So if we put those together, what do we get? 7y. So we have 2y squared plus 7y minus 15. And just as Janine had said earlier, it still needs to be in standard form. So the biggest exponent has to go first and then follow its way down. That's it. Problem's over. Any questions, 3 or 4? Hopefully it's not as hard as some thought it was going to be. Not hard, it's our thing. All right, so let me give you a 1-minute head start on example 5 before we get started with number 5. So again, I'm going to show it both ways because I don't know which way you get it. I'm going to show example 5 both ways because I don't know which way you get it. So if you distribute, you're going to take the w and multiply it times the whole, set in parentheses. So w times 2w squared plus 9w plus 4. Then you take the 5 and distribute it. Now, the 5 has a negative sign in front. Since the 5 has a minus sign in front, you have to keep the minus sign in front of the 5. It is now forever attached to that 5. It is now forever attached to that 5. So now we distributed it out. So w times 2w squared is 2w to the third. W times 9w, 9w squared. W times 4, 4w. Minus 5 times 2w squared is minus 10w squared. Negative 5 times 9w, negative 45w. Negative 5 times 4, negative 20. Anyone with any questions so far? Then we combine our like terms. 2w to the third doesn't have anyone to go with. So notice I started with the biggest exponent. If I start with the biggest exponent, then I don't have to worry about not going in order. If I start with the biggest exponent, I don't have to worry about not being out of order. 9w squared minus 10w squared plus 9 minus 10. What kind of one? Negative 1. So negative 1w squared. 4w minus 45w is negative 41w. And then minus 20 just coming down. So it has no one to go with. There's your final answer. That's distributed. Any questions on distributing before we do it using Punnett squares? So for Punnett squares, there are two ways that you can set it up. There are two ways that you can set it up if we're using Punnett squares. You can put w minus 5 on the left, and then 2w squared plus 9w plus 4 at the top. Or you can put 2w squared plus 9w plus 4 on the left, and then w minus 5 on top. So either way it goes, you're going to end up with the same answer. Either way you set it up, you're going to end up with the same answer. So let's work this part out. W times 2w squared is 2w to the third. W times 9w, 9w squared. W times 4, 4w. Negative 5 times 2w squared, negative 10w squared. Negative 5 times 9w, 45w. Negative 5 times 4, negative 20. So if you set it up in Punnett squares, here's all your parts. There's my like terms. There's my like terms. Combine your like terms and you're finished. That should be a minus 45. There you go. That's some stuff up there. I got on the phone, y'all. It's messed up. See how nice y'all are. So there's your Punnett squares. You chose to do it that way. If you set it up the other way, you'll get the exact same answer. Yours will just be in different spots. Any questions on example 5? Again, it's not hard. You have a choice with the way that you do it. Pick whichever way that's going to work for you and roll with it. So let's do example 6. So for example 6, I'm going to show it using the Punnett square. But if you prefer distributing, you do what you do the way that's going to make more sense for you. So for example 6, I'm going to use the Punnett square. First parentheses. So Sam, did you put yours on the top or on the side? top, so we're gonna put 7 into the third, plus 2n minus 4 at the top. So 2n plus 1 on the side. So we start multiplying out. So 2n times 7n to the third. So 2 times 7, I know is 14. What's the exponent for the n? 4. N to the first, n to the third, add the exponents. Remember, when you multiply, you add exponents. So 2 times 2 is 4. What's the exponent for the n? If I take n times n times n is n squared. Remember, you add the exponents. For some of you, you may need to put that 1 up there as the reminder. Remember, n means n to the first. N means n to the first. 2n times negative 4, negative 8n. One is such a beautiful number. If anything times 1 is itself. 7n to the third. 8 the interference is 4. 2n minus 4. That's what we get when we multiply everything up. Do we have any like terms? Any like terms sitting in those boxes? 2n minus 8n. Those are the only like terms we have. So 14n to the fourth plus 7n to the third plus 4n squared minus 6n minus 4. Again, just remember, your final answer has to go in order from biggest to smallest. Biggest exponent, smallest exponent. Biggest exponent, smallest exponent. Any questions before we at least get through the last 2 examples? If we don't get to example 9, I'll make sure to record that before I post it to the class. And we're still looking at example 6. All right, example 7. So, there's only one thing different about example 7. What is it? Look at the 2 parts of example 7. What's the only difference? One's a negative 2 and one's a positive 2. Does it change how you solve it? No. So if you want to distribute, distribute. If you want to do Punnett squares, do Punnett squares. I'm going to distribute since I did Punnett squares for the other one. So take 3h, multiply it times 3h minus 2. And then take positive 2. Multiply it times 3h minus 2. So everything gets distributed. So now it's multiply. What's 3 times 3? 9. What's h times h? H squared. 3h times 2? 6h. So minus 6h. 2 times 3? 6. 6. 2 times 3 is 6. 2 times negative 2 is negative 4. Do you have any like terms?
Negative 6H
Negative 6H, positive 6H. Those are opposites, so they cancel out. Negative 6 plus 6 is 0. So they drop out. 9h squared minus 4. That's a special case that will show up sometimes. That's a special case that will show up sometimes. Example 8, which is the last example that we'll get to do, is another special case. So example 8 is another special case. So then that would be 40y squared plus 21. And then you multiply that squared by y. All right, problem 8. So problem 8, you have 5t plus 2 squared. So in order to understand this, you have to understand what it means for something to be squared. So if you take 10 and raise it to the second power, what are you doing? You're multiplying 10 to itself. If you have x squared, what does that mean? X times x. So that means if you have 5t plus 2 squared, you are taking 5t plus 2 times 5t plus 2. So you have to write it twice. First thing you do is write it twice so that you know what you're talking about. There are a lot of people who get this wrong because they don't interpret it correctly. Not just Algebra 1 students, there are college students that get this wrong because they don't interpret it correctly. 5t plus 2 squared means write it twice, and then you can do it in whichever method you choose to. Distributive property, Punnett squares, whichever way you choose to do it, then you do it. So let's roll with, yes, go ahead.
Okay, so if you know the same, like 5 times 5,
Mhm.
could you just do 5 times 5 times 5, which is 25, plus the 1, would be 2 to the third power, right? Like, so 25t. Like,
It makes sense, but this wouldn't be to the third power.
okay.
So if you have 5t, so 5t times 5t, so 5t times 5t plus 2, and then 2 times 5t plus 2. So I'm doing it using distributive property. If you were to set it up using Punnett squares, that's okay too. There's your setup. There's your setup if you're doing Punnett squares. So not only the first part of what you said was correct, 5 times 5, 25, but t times t, t to the first times t to the first, t squared. It's a soft interference. 5t times 2 is 10t. 2 times 5t is 10t. 2 times 2 is 4. Okay, John? There's your like terms. What's 10 plus 10? 20. There's your final answer, and it's already in standard form. Any questions on example 8 before we wrap up? Example 9, I'll post before I upload this. So lastly, let's check out example 9. Example 9, we're finding the area of the given triangle. Of course, area 1/2 base times height. So if you remember with the area of a triangle, you have your base, and so you have your base and your height, which are connected by the right angle. So your base, 10y plus 5, your height is 4y. So when you originally set up the problem, you have your area equal to 1/2 times 10y plus 5 times 4y. Now, if you want to use Punnett squares for this problem, my advice is that you have to do them 2 at a time. You have to do it 2 at a time. So if you're going to use Punnett squares for this, you have 1/2, and you've got 10y plus 5. So that's 1/2 times 10y, which is 5y, and then 1/2 times 5, which is 2.5. So that means you took care of the first 2 parts, but now you have to do 4y. So now you take 4y, and then 5y plus 2.5. So you use the answer from your first Punnett square to the second Punnett square. 4y times 5y is 20y squared. 4y times 2.5 is 10y. So your answer ends up being 20y squared plus 10y. Now, you can just as easily get the same answer by doing distributive property. So if you do distributive property, you'll still get the same answer. Distributing, you do 2 at a time. So 1/2 times 10y plus 5, 1/2 times 10 is 5y, 1/2 times 5 is 2.5. And then 5y times 4y is 20y squared. 2.5 times 4y is 10y. So you end up still in the same place. So case in point, if you want to do it using Punnett squares, you can. If you want to do it using distributive property, you can. Again, the choice is yours. Just pick whichever way is going to work for you. So with that, that completes section 7.8, which finishes off the unit. Please make sure that if you have any questions, please make sure to ask. Other than that, have a great rest of the day, and I'll talk to you soon.